Welcome, Professor Sudhir sir.
Good morning.
Good morning. Good morning, Sudhir sir.
Good morning, everyone.
Thank you, sir. We'll start in 5 minutes more, sir.
Sure, no problem.
Yes, thank you, sir.
Sir, good morning, sir.
Good morning, Professor.
Good morning, everyone.
Tamarai,
Yes, sir.
we can start.
Sure, sir.
Yes.
A very happy morning and warm greetings to the bunch of brainy crew gathered over here for an enlightening webinar on the topic Commercialization of Lab Technologies and Tech Transfer, organized by Department of MBA IEV in association with Institution Innovation Council and IEDC cell of Puducherry Technological University. The best preparation for tomorrow is doing your best today. Now, it's my pleasure to welcome Dr. N. Shivakumar, Program Coordinator of MBA, to deliver the welcome address.
A warm good morning to one and all. It's indeed a great privilege and honor for me to present the welcome address for today's webinar titled Commercialization of Lab Technologies and Technology Transfer. It's indeed a great honor for me to welcome the man of vision, Dr. S. Mohan, our Vice Chancellor of Puducherry Technological University. Sir, I wholeheartedly welcome you, sir, for this particular webinar. And I welcome Dr. B. Hemakumar, the convener of IIC, Institute Innovation Council of Puducherry Technological University, who's taking care of this particular event. I welcome Dr. B. Hemakumar sir. And next, I would like to welcome Dr. Sudhir Vardharajan sir, who is a presenter of today's event webinar, and he's Dean of Design and Innovation and Incubation, and Head School of Design and Innovation at IITDM Kancheepuram. And sir, it's very glad to have you for this particular wonderful webinar. And our students are very much keen and interested to have your session, sir. So I also welcome all the participants of today's webinar, like Department of MBA students and other interested students are also participating in this particular webinar. As a whole, I welcome each and everybody for this particular webinar. So thank you.
Thank you, valuable words, sir. And now, it's my honor to welcome our. It's an honor for me to welcome Dr. S. Mohan, Vice Chancellor of Puducherry Technological University, to deliver the presidential address.
Very good morning to all of you. So, welcome Professor Sudhir Vardharajan, the chief guest of this morning function, and the coordinators of this. I would like to say a few words about what we are expecting out of this thing. In fact, now India is becoming one of the top 50 innovative economies globally. So I think we are going very fast on that particular thing. And also, especially on the use of artificial intelligence, data science, solar energy, climate research. So these areas are something which is leading, and also the space technology. So these are all demonstrated little more. There is a lot of requirement that it is needed in our country. It is not that only cities will get the benefit of AI and data science, but also the rural areas or the villages also should be able to get a good thing. Then only it becomes a sustainable country. Otherwise, we develop one particular area and leaving behind some of the people. I think that may not work. So in that, I think the Atal Center and also the Institute Entrepreneurship Development is more aiming at trying to look at not only on urban areas, but also create some good facilities like providing the urban facilities. So the late president of our country, Abdul Kalam, has told Pura. So that need to be also looked into it whenever there is something that we can develop and then demonstrate to the people. It is not only at the city, but also look at something that the local need. And also, like, Pondicherry is very famous for a lot of fishing community are available and they are going every day to see. So can we not develop some or design, innovate some technology for them to communicate? This is also very much needed, that we may have to look at on all these things. So our job is not only knowledge creation and knowledge dissemination, which is normally we do, but also now we may have to look at the knowledge deployment and commercialization. And also it should benefit to a large community rather than only for academics or academic interest. So it has to go to the field. Lab to field is very important. So for an example, that we may have to look at developing a communication technology for the fishermen when they go inside the sea. They may not have any communication for them to communicate if they have a small trouble somewhere. So I think these are all something that we may have to also look at what it is actually needed in the field or in the ground reality, and then look at something on that, rather than we have a lot of innovative ideas, but at least I would say some 30 to 40% of the projects what our centers are taking, or the Institute Entrepreneurship Development Center, should be of local needs or the societal needs also. So maybe, I would say the solid waste management is one of the major issue in many of the uh, cities and also the rural areas. So let us do something on an innovative technology with a sensor or a test bin with a sensor, so that it doesn't create a problem in the local areas. So maybe we may have to look at on all these things. We have been very good in the Atal Center and also the good reputation that would we have, and the team has been working very well. And I'm very happy that today Professor IITDM Professor Sudhir Vardharajan is here, and his expertise will really, what he is going to share will be of very helpful to all our people. I think almost around more than 150 participants are there. I think that they have to take it and do some innovation. Okay, these 150 people, out of that, if they do something, at least one third is on the societal needs. I think that is what the PTU name will go to the people. Otherwise, we will be only doing academic. We have to do something which is for the society. And I would like to request all of you to come with an innovative idea to solve the problem of our people, so that that should not be like. The second point is, I always say that every year we have been worried about the flood, and there is a lot of problem, flood damage, flood. Why not we do something on prediction? Can we not do some good instrumentation on when the flood started coming from upstream? Let us inform all the people so that there is no trouble. Because even last but 1 year flood in Kerala took away around 535 people alive. Why we have to do this? Can we not do some? The technology can help to stop this real loss, because we may not know, even 1% loss in a family makes that family to come to the very disaster situation. It is a real family disaster. So we have to do something on developing technology and make it commercialization in one. But I would request what the society needs, the immediate society needs, that need to be looked into it, and make a brainstorming on that, and then come out with this is what it is really required. Let us concentrate on that. Okay, we can do a lot of other innovation, but at least I would say one third of the projects or innovation should be of social needs or local needs, or so that many people get benefit out of it. It is not going to be within our domain of PTU campus or any engineering college campus. I would always say everything to be done for the society. Then only, because society only created us and our colleges, our IIT, IITDM, everything is society has created. What we are giving back to the society? This is a question that we have to always ask ourselves and develop something, a new finding, so that finally you will also be have a satisfaction, your family will have a satisfaction, your state will have a satisfaction, and your university will have a satisfaction, or your institute has a satisfaction. Please work on that kind of a development of some innovative technology to solve the problem of the society. Okay, so because they cannot find, it is only you have to give them the solution as such. Okay, so I hope this even though we have the COVID is major issue, but we have been very good in developing the vaccine, as well as solving the problem, distribution. Everything was a challenge, but we could uh, really manage that particular situation. So we are very good in crisis manager, but at the same time, after the crisis over, we forget about it. So on the other hand, this crisis gives lesson that we may have to prepare a technology or some kind of an instrumentation which can identify and then help them so that, initial stage itself, let us solve the problem rather than making it as a big one and then try to say solve. That may not be a good thing. So as a technocrat or as an engineer, we with that particular thing. Already it has happened. So next time when it have this many lives should not go up. So that is the only point that I would like to make. So I hope that this kind of a seminar will encourage the young people, and Professor Sudhir Vardharajan would give a lot of inputs for all of you. So I would once again, I request that we may have to work on some problems which are socially relevant. Okay, and it may be urban areas, but don't forget the rural areas also, or maybe the poor population. We have to give them a thing, and they will be much more happy to receive that particular kind of a new development. Okay, so thank you very much for inviting me to uh, inaugurate it and also present over this, and I hope that this will be highly useful to all the participants. Okay, so thank you very much, and I once again thank Professor Sudhir Vardharajan for accepting to deliver these lectures, so that there are more than 150 students will get benefit out of it. Thank you, Professor Sudhir Vardharajan. So, and all the participants. Namaskar. So I have another work. I may not be able to continue to sit here. So, but I hope to get your presentation to look into it and get the thing. Okay. So please make a visit sometime after the COVID is come to a thing. So you are welcome at any time to come over here so that you can see the actual development, what it is happening here, and give your suggestion. Thank you, Professor
Thank you,
Sudhir
sir.
Vardharajan. Thank you all.
Thank you so much, sir, for your encouraging, wise, valuable words. Now, it's a privilege for me to invite Dr. V. Hemakumar, convener of Institution Innovation Council of Puducherry Technological University, to give away the chief guest intro.
A very good morning to one and all present over here. So, indeed, I'm very happy to be a part of this event. So, thank you. So, first and foremost, I would like to thank, before I start, introduce our esteemed chief guest today, I want to thank our Honorable Vice Chancellor who has agreed to preside over this event. So today's topic, we have commercialization of lab technologies and tech transfer. So before, it's my honor to introduce our chief guest, Dr. Sudhir Vardharajan. He is the Dean and Head of School of Design and Innovation in Indian Institute of Information Technology Design and Manufacturing, Kancheepuram. He is also the founding director of Medit Innovation Foundation and president of Institute Innovation Council. So he basically earned his BTech degree in mechanical engineering from Osmania University and did his post-graduation in industrial management. So from IIT Madras, Chennai. After completion of his MTech, he obtained his PhD in the field of systems approach from the same college. So he started his career as a software engineer for 1 year in a leading Indian IT services company before his PhD. Also, he worked with 2 of the top 5 Indian IT firms and one of the earliest software product firms in India. In addition to this, he delivered consulting engagements for global corporations from North America, Europe, and APAC. And apart from this, business consulting and system research, advisor for strategic accounts, and vice president of BFSI strategy and innovation are some of his professional services. Now he has around 26 years plus of industrial and academic experience in strategy, design, and innovation. So the subject area that he specializes are in the management consulting, change management, strategy, analytics, leadership, solution architecture, requirement analysis, IT, and business strategy and business transformation. This area of research interest includes management of the fuzzy front end of the product innovation in general, and the emerging smart connected products, particularly in the context of cyber physical systems. And most importantly, is also the author of a book called Managing Nothing, a narrative inquiry into the innovation and leadership in the IT industry, which was published in August 2015. So we are extremely elated to have you, sir, today on this morning. Okay, so thank you for accepting our invitation, and we are very much ready to hear from you. So I request you to take over the session, sir. Thank you very much, sir, for accepting.
Thank you, Dr. Hemkava, for the introduction, and also thanks to Dr. Shivakumar
Yes.
and also respected Vice Chancellor. So thank you all for inviting me for this session. And also good morning to all the participants here, all the students and faculty members who are present here. So I'll speak like last, apart from my industry experience, last 5-6 years, I've been involved in the academic institute and essentially building a innovation ecosystem in this institute. So I'll to a large extent share from that experience what we have been doing and some of the challenges that we see in terms of how one can look at the technology transfer and especially commercialization of lab technologies. That has been the topic. But also the points made by Dr. Mohan, Vice Chancellor, are very relevant for the discussion which we are going to have, especially looking at the difference that institution can make to their local context. Now, this has been a very strong theme in the way we have built our incubator and the entire design-centric program or the School of Design that we have set up. So I'll share certain models of the kind of shift which is happening in engineering education and logically where things are heading, and therefore what is the real role of students in this whole process, and especially the incubator. They have a major role to play in this whole process. So those are the points I'll try and elaborate. So I'll start by sharing my screen. So I hope all of you can see the screen presentation.
Yes, sir.
Okay. So let me start with the first point, which Dr. Mohan also touched upon, is looking at really the whole idea of innovation. What is the kind of interest in this concept of innovation today at a national level, right? So one of the things you would have noticed is the Global Innovation Index. In 2021, India was ranked in 46. Now, this is a steep jump that we have had from 2015. So where we were ranked 81 in 2015, and recently we have moved to 46 in 2021. So in the 6 years, it is almost like 35 ranks we have tried to move forward. Now, the journey from here may not be as fast. It will be a lot more steeper, because if you look at the actual scores there, so we have about say 36 or 35, 36.4 as a score. But if you look at if getting into the top 20, it is almost 50. So that's journey may be a far more steeper going from here to the next levels, because last couple of years, if you see, the rank has only increased by one number or so. But this advancement, the last 5 years progress, has been largely because of some of the Government of India initiatives, starting with the Startup India initiative, which was launched in 2016 or 2015. And then subsequently, this launch of IIC happened in a lot of academic institutions. Then the ARIA ranking was also launched. And then the National Innovation Startup Policy, the IPR policy guidelines, all these have been introduced in the last 3 to 4 years. And these have played a major role in terms of the improvement in the ranking. And among the various parameters in the ranking, if you see, one parameter where we actually are very good is where we are ranked at 29. is in the advancement in the science and technology area, which is largely coming from the proliferation of engineering colleges and some of the colleges adopting these kind of policies and taking steps to look at technology creation and other things. That is clearly showing up in the data on this rankings. So we are actually going in the right direction in terms of the overall policy and the way the things are being implemented in different institutions. But the way actual implementation happens, and there could be a lot of challenges. And so that is where it is important for academic institutions to understand what is really happening and to facilitate this process. Otherwise, it can get into a lot more difficulties, and kind of frustrations will be far higher. But so it is important to understand the broader trend and the kind of adaptations or changes required at an institutional level. One needs to carefully look at that, because each institute may have to adopt it in different way depending on its situation, its resource availability, its kind of ecosystem, its kind of partnerships. They all differ. So it is not like a one size fits all. It will not apply. While the guidelines of innovation startup policy are given, each institute needs to tweak it and adopt it in the way it makes sense to its context. Now, this is what I will highlight in terms of what are those things one needs to actually look at. So first thing for all of us to understand, whether you are a student or whether you are a faculty or whether you are an organizer or a CEO of an incubator and whatever it is, one needs to understand that there is a gradual shift happening in the expectations in engineering education, or the models of engineering education are gradually shifting towards the right. Now, what do I mean by shifting towards the right is, traditionally, if you take these three bubbles, science and technology, product and society, these have existed for a long time, since the day we started colleges. All these elements were there. Now, where the primary focus of institutions, academic institutions, was essentially on the last bubble, the science and technology bubble. Whereas subsequently, we have had so many things coming up. If you see the history of engineering education, the science-led engineering was a very dominant concept. It started off in the 1950s in the US. Prior to that, engineering was a practice. Engineering was a practice. It was like a medical profession. So people were practicing and understanding from that, and then developing solutions and then improving their solutions. This is how engineering was done. But in the 1950s, a shift started coming within the US, where they said science has to play a much more dominant role. This was again driven by what happened in the World War. The atom bomb won the war. So people started believing that science should play a more dominant role. Instead of practice, it is the theory which should drive practice. So this was the kind of shift which started coming in the 50s, and subsequently when they started IITs in India and all, most of the IITs tried to adopt this model of science-driven engineering, right? And this, while it is useful, there are a lot of things which have not been absorbed into this model. For example, the quality revolution which happened in Japan happened outside this model. Whether you take the information technology revolution across the world and even in India, if you see, when IT industry started developing, they started developing on their own. There was nothing like the academic institutions supporting manpower development for IT in the early days, in the 1970s and other time frame. If you see, it is the industry which went and set up computer science department. In computer science, the IIT Kanpur's computer science department was started by initiative from TCS. So it is much later, only in the 2000 time frame, that the IIITs were set up to meet the manpower requirements of the IT industry. But you can see the IT industry started in 1970s, but the academic institutions came much later, right? Similar thing has happened in entrepreneurship. While entrepreneurial world, the startup world and other things have been developing, you look at the entire Silicon Valley kind of structure. They all happened a little bit in that ecosystem before. It is not broad, widely spread that all institutions were doing this. A pocket of institutions, it was happening. So some of these initiatives, and today we have sustainability, Industry 4.0, and many other things which are coming up, and even today this entire online education and other things, these are all coming outside the academic environment, and then we are expecting the academic environment to absorb this, right? So constantly when you look at this, it is like new requirements from the society, new requirements in terms of how products have to be developed. These have been slowly being infused into the engineering education process. So as a result, what happens, there is a challenge on the curriculum, right? What is originally thought of as a standard engineering curriculum now has to add new elements in the curriculum to accommodate these new requirements. And many times it becomes a conflict, saying this is what we mean by engineering, and now if you have to accommodate a new course on entrepreneurship, which course do I remove? Because at the end of the day, an engineering program is 4 years, and a student has only certain time, and the faculty has a certain time to run the program. So how do you accommodate new requirements within this? So there are different challenges emerging where some courses may have to be combined, some courses may have to be done in a different way, right, to accommodate these new things. So that is the gradual shift which is happening. Now, technically also you see, when we talk about economic value, at the end of the day, why am I doing any manpower development or any technology development? To make a difference to the society. That's what Dr. Mohan is saying. At the end of this, all this has to go and make and create some economic value in the society. Economic value cannot be created by technology on its own. Technology has to translate into a product for that to create an economic value. Now, when you talk about technology versus product, technology, you can have a patent and one patent on one technology. But when I build a product, there may be multiple patents required or multiple technologies required to build a product, right? So it's a different ballgame. When moving from a technology to a product, it's a kind of a different kind of challenge. So if I have to talk about mobile phone, I'm told has more than 500 patents inside, right? These patents may have been developed by different companies, different institutions. But mobile as a product has multiple patents built into it. So what becomes very important in this journey when you are moving from left to right is an institution and its faculty alone cannot do this journey. It is creating the entrepreneurial ecosystem in the institute and building teams of students who want to potentially take entrepreneurship as a career. That becomes a very important part of this movement from left to right. It cannot happen by just a faculty superhero producing technologies for the world and then licensing them, right? It is creating a group of student-led startups, which is eventually going to proliferate and make a difference to the society. So that's why entrepreneurship and entrepreneurship again is not a solo job. It is a team. Building these teams becomes a very crucial part, and an academic environment actually gives you an opportunity to do that, because this is where very nice partnerships can emerge among students. So this broad trend is something I want all of you to understand, that this is the direction things are already moving. Now we need to recognize this trend and see how best we can enable that. Now let me look at the same trend from a slightly different perspective. Is when you look at inventions. Inventions is essentially novelty or a new idea or a new technology which has come up, right? But this can happen at any level. So I have given you a kind of spectrum of levels, starting with the business or market scenario, then the product concept, and the product is built out of subsystems, and each subsystem may have certain components and each component may have certain parts. Now, when you look at this kind of hierarchy, you can see that innovation or inventions can happen anywhere. Any of these rows, you can have an invention. But when you say innovation, innovation has to cross across, or it has to connect all these dots. Across these levels, the dots have to connect for something to become an innovation. Because then only when you create commercial value, economic value in society, then only you start calling that as an innovation. So suppose I have come with a new invention at P11 at a park level. I can license it as an institute, I can license it and make some money. But whether this thing gets used in some building a component, or whether that component goes into some subsystem, whether that subsystem becomes part of some product, and whether the product gets really starts creating value in the market, that we don't have any control on. But unless this whole cycle happens, we should not call it innovation. So innovation means this whole levels have to be traversed. Invention can happen at any of these levels. Now there are different types of inventions. So some people call it as a business model level. Some people call it at a product level. Some people can do it at a technology level. Some people can do it at a science level, right? So I'll give you an example to illustrate this point. So all of you would know something called non-stick pans, right? Non-stick cookware is very common today. Whether you're making dosa or any other things, people use non-stick cookware. But where did this come from? How did this non-stick cookware emerge? So if you go and look at the history of that, what it shows is it happened in France by a company called Tefal. Now, how did this company come up with this product called Tefal? Right. So it is a story about a person. He's working in, say, a R&D organization like a CSR institution or some ISRO type of institution. He's an R&D person working there who is working on some materials. And so when he was working on some materials, he had his own personal hobby of doing some fishing. So he was struggling with getting a right fishing rod material for a fishing rod. So as he was exploring, one of his colleagues told him that DuPont, which is one of the large companies, chemical companies, they had come up with a material called PTFE, polytetrafluoroethylene. Now the discovery of polytetrafluoroethylene itself is an accident. So what the DuPont was actually working on an experiment to create a non-toxic refrigerant material, gas. So one of their researchers was working on some composition, and he left it around one night, and then next day he came back to see whether a new gas has formed or not. Finally, what he found was some solid mass was created by that experiment. But what they found was that solid mass had a very slippery characteristic. Then they did some more research on that, and then they found that it was polytetrafluoroethylene. While they were trying to get tetrafluoroethylene, they ended up with some polytetrafluoroethylene. And then they started seeing that there could potentially be other applications for this. So that is what DuPont as a company was doing, and they put out this material in their brochures and other things circulating among industry, saying they have come up with some new slippery material which could be used for different purposes. So that idea, this person then had taken that idea and experimenting with this fishing rod. But what was also happening was he was a married person with 3 young children, and his wife was having trouble in creating pancakes and boiling the milk simultaneously. And so they were getting burnt and other things. And so she had once complained to him saying, why, instead of wasting your time on some fishing rod, can you figure out a problem for this, right? And that is where it stuck to him that what he's working as a slippery non-stick material, can he put it on a saucepan? So this trigger, you see the kind of connections. One connection emerged out of an accident. Second, somebody tells about this material in connection with a fishing rod. And third is at home, something happens where suddenly they see a connection between what he's working as a slippery material and the saucepan requirement, right? So then he started working on this connection between these two. Now you can see at a scientific level, there is an innovation of a new or an invention of a new material called polytetrafluoroethylene. But it is not a product. For DuPont, it is a product they can manufacture and sell it. But beyond that, somebody had found that maybe this can be used to come up with a non-stick pan. But then what is the challenge? How will you stick polytetrafluoroethylene on an aluminum surface? This becomes a technology problem. So then he started experimenting with the aluminum surface and different ways of trying to get this material to stick to the surface. So one of the experiments when he was doing, he noticed that when you etch that aluminum surface, there are some small pores which are forming, which are slightly uh, wider cross section of the pore inside compared to the entry on the surface. The surface is only a small dot, but inside it is forming a small pore. And when you pour this tetrafluoroethylene on that liquid one, there is a tendency for this to go and get stuck in that pore. So when he discovered this connection, then only he started coming up with a technology to mass manufacture this concept. That is a technology level innovation. But then what does he do? He's currently working in a company, in a R&D unit in some government organization. So therefore he saw that there is a opportunity that he could potentially get into a home appliances market. Now this is where the translation of technology to product and a potential business opportunity starts happening. And initially he pitched this idea to a few people. They did not seem to understand. Nobody backed him. Then he and his wife took a call to come out of that company and start this venture. And then this whole revolution around non-stick cookware started happening. And the Tefal product brand was born. And today it is one of the few companies in France that has not done outsourcing to save itself, to reduce its cost. It continues to innovate in this direction. So this is what you will call ideally as a deep tech type of company, where the idea is flowing right from science to technology to product to business. But that's a very long journey. It's not an easy journey. For many of the students, the journey can start anywhere. Because as an engineering student, you may not have all the depth of these things when you are studying. But your ability to see and understand what is happening in the society could still be there. Because there is technically no major expertise in that. It only depends on your observation skills. If you are able to observe things around you which are really there is an opportunity, there is a challenge people are facing, then based on looking at the users' needs and how users are using certain things and what difficulties they are having, you can bring in what is called design-led innovation. So you can start with a product concept, then go and look for what technologies will make sense for this and then put them together, right? Or like what you have seen in the movie Surarai Potri, that's a business model innovation where he's not creating any new technology, but what he sees is, can I bring down the cost structure of an entire airlines business? Now this is again not new. Southwest Airlines in US has already done that, but in India nobody has done that. So he says, how can I bring a new cost structure where I can reduce the cost of overall travel and bring it down to a very low level where a large volume of people can travel. So it is a business model innovation. You are trying to look at what is the size of the aircraft, what is the waiting time in a airport, and what is the kind of services you will offer in a airline. All these things can you rationalize and then come up with a new business model structure. So if some of you MBA students who are doing entrepreneurship and all, you can look from this perspective. If you analyze the value chain of a particular product or a particular business, that is where you will start getting this clue of how do I break the cost structure of any business. And that can in turn drive you to find the product or find the technology, and you can partner with different people to build this kind of thing. So the point I'm making is that inventions can happen at any level, but innovation, if it has to happen, you have to connect all these levels. And the type of invention and the kind of value capture can influence your commercialization strategy. Now, I'll give you another example here. There is a company which I had consulted when I was in the industry. They came up with an innovation which is a very small point innovation. That is, they came up with an idea saying, if I give a certain type of capsule, which is a herbal-based capsule, to a cow, I am able to see increase in the vitamin A content in the milk. So this is a discovery they made through some experimentation. Now the question for the company is, they went and patented that capsule. Now the challenge for that company is, what do I do with this capsule? If I sell the capsule, if I manufacture and sell this capsule, I'll get 5 paise per capsule. And I need to spread the capsule around the country and other things. I need to have a mass production facility to make some profit in that. But where is real value in this? The value is not in the capsule. The value is in the milk, vitamin A enriched milk that the cow is creating. Suppose he sells this capsule and the farmer buys and uses it in his milk and he is able to sell that milk, he may get a little more marginal extra revenue than what he's making. But the person who actually processes that milk, the processing plant or the milk processing plant, who processes the milk and separates the fat from the milk, they are the ones who can potentially get maximum value, because the value of vitamin A rests in the cream. And those who are able to extract the cream can actually sell that and make more money. So then the question becomes, how do I commercialize this? Do I just sell this individual piece and leave it? Or do I set up an entire milk processing plant? That means, do I become like Amul, where I have my own suppliers and I aggregate all the things, I have my processing plant, and then I will make finished products out of that milk, like paneer, butter, and all those things, and then sell and make money? Or is there a different way? So the business model we had proposed was a slightly different thing. I cannot reveal the details here, but it does not require you to make all your investment, but you can work with a different franchisee model to do something else. But it requires a strong technology backbone, information technology backbone. So the company can actually build a strong strength around not only this patented capsule, but a unique supply chain technology model, and use that to drive the entire business. So this is how one needs to look at when we start looking at what is the technology, what is that invention, where the value lies, and then how to capitalize it. One needs to look at this whole process to explore that. So if it is point into inventions, you can always license it and make some money, but you may not get the real value out of them. But if you want to get a value, you need to start looking at the other levels. And when you look at the other levels, an entrepreneur is required in your ecosystem to do this. A faculty cannot do this. Faculty has so many other responsibilities, and they may not be in a position to, even if NISP says faculty can start companies, assuming an institute has 100 faculty and 10% or 15%, not more than that, will really look into it. So suppose say 10 faculty want to start companies, that will only create some value. But if 10% of your students want to do this, and if your student base is 3,000 and 10% of your students want to do this, that's a different market. That's a different impact. So that is the direction one needs to really look at when you talk about commercialization. While the faculty-led commercialization is one angle, the entrepreneurial-led commercialization is the aspect where real value lies. So I'll now paint the outline of how these models have evolved in academic institutions. So if you look at the traditional model of what you call as sponsored research and industrial consultancy, is essentially a faculty-centric and a cost-centered model. So there is governments give some teaching grant, governments give some research grants. So your departments then take some PhD students or PG students, faculty gets some professional development allowance, you form some doctoral committees, and all this leads into some, say, faculty research, which could be publications or potentially patents or whatever it is. And traditionally, people have been looking at publications and at most citations. So what is the impact you are having? And this may lead to further some acquiring some research grants, creating some research labs, or potentially doing some consultancy to companies. And some of the overhead that comes out of this goes back into the institute corpus. And this institute corpus is again given as seed grant to some young faculty or to support the research centers in the institute. So this is typically one kind of model which is prevalent in institutions. Next, what we had is the faculty-led IP creation. So there has been shift towards, like if you look at the IITs in the 1990s, there was no, this is what they were doing. They primarily industrial consultancy sponsored research was happening. But after that, the governments have been asking IITs to say you should be producing patents, you're measured in terms of patent production and all that. So people started saying, okay, I'll start producing patents. But when you start producing patents, you need funding for that. So again, the institute corpus or alumni funds or any of these things are used to support the patenting activity. And patenting, what does it involve? The faculty has to disclose any invention which has been created. Somebody has to first disclose to the IPR cell. You need to have an IPR cell and somebody has to disclose. And when it is disclosed, you have to take a decision whether this is to be funded by the institute or is it done along with some external company, whether it can be jointly patented, whether you want to patent within the country, whether you want to patent outside the country. All these kind of discussions happen and then the filing and process happens. Now, typically the patent filing and granting is a very long time consuming activity. So if you file a patent to get it published, it may take 2 years. Now today they have introduced some mechanisms to make it faster. So you can publish in say 1 month. But then from publishing to granting can take anywhere between 3 to 8 years. Like yesterday, I was seeing one of my friends in IIT, he had published something on LinkedIn saying his patent is granted. He has applied it in 2013. It is granted in 2022. So patent granting is a completely different life cycle. But the moment you publish it, you have a certain element of defense. And patent is a defensive strategy to a large extent. Patent is a defensive strategy. It is only saying I have this is there and others should not do this, right? And initially, when companies are or institutions are publishing patents, it's more like a signal for reputation that this institute is producing a lot of patents means it creates a positive impression in the ecosystem and maybe more companies will come to you for offering sponsored research and those kind of things, right? Next stage is where a faculty-led patenting is pushed into revenue creation. So which means you now start asking, okay, you have got so many 1,000 patents you have got as an institute, how many have been commercialized? How much revenue, licensing revenue are you able to get out of this? So when that question starts coming, then an institute has to actively market these patents, which means you need a different technology transfer office. It is no longer an IPR cell, it's a technology transfer office where you need specialists who can not only understand technology, variety of technologies, because an academic institution will have a variety of departments. So somebody in mechanical, somebody in electronics, computer science, different types of technologies may come. So you need people who can understand variety of technologies and their market needs. Where will they fit? Which company may really be needing this? And then somebody who has to actively market this. He has to reach out to industries, bring them and showcase these technologies, talk to companies, and it's actually a consultative selling process which has to happen, which most academic institutions may not be prepared for this. It is not a question of hiring a junior guy and putting him and then saying you manage this. It's not going to happen like that. You need real expertise and people who have done technology transfers to participate in this process. Faculty themselves can do, but then there is a limitation. A faculty can market his product to an extent. His patent, he may be able to find some customers and do it. But each faculty does on his own. All faculty may not be in a position to do that, may not have the skills to do that, may not have the connections to do that. So these are all the challenges that academic institutions will face when they move into this stage. Then the next question comes, okay, how much licensing revenue can we get out of this? And how do you price this? How do you charge this royalty? What kind of contracts you need to have? And what is the additional development cost which is involved? Just my patent may be granted, but is the patent technology readiness level sufficient for that to be used by a company to make a product? May not be. So there is an additional investment that companies have or faculty or the teams have to put to make that technology really useful to that company. So these are all the additional costs one will need to really look into. So where this kind of model really works is for very good institutions which have a strong research base, where they have good quality researchers who are already producing have got some good reputation, producing strong patents and other things. And the ecosystem, there are a set of companies who are already networked with them in some way, then this model can work. But if it will still not lead to wide impact unless it is in areas like pharma, where somebody does a drug discovery and it has a wide impact and those kind of things. But in other kinds of technologies, it may not have a wide societal impact. At the end of it, you may sell a technology. How the technology translates into a product and how the product is commercialized may be a much longer journey, right? So you need a company which is willing to do that. So if you have a company partner who has the sufficient resources to do that, then this kind of models will work. Otherwise, a lot of faculty energy will go in, but the outcomes may not be commensurate. So this is a challenge that one will have in this model called level 3. Now this is where the fourth model comes, which is really creating this entire student-led entrepreneurial ecosystem, right? Now, instead of my doing research and producing a patent, finding a customer and then marketing it to him and then creating license revenue, which is a very long process for a faculty to get involved. If the faculty also work as part of their teaching, if they also work with students to promote the entrepreneurial orientation, design orientation among students, and promote this student-led innovations, which is where groups like the Institute Innovation Council or all that is being done through this mechanism essentially has to start playing a role. So when you promote student-led innovation, there are two challenge options which are emerging. The first is that students themselves may come with new insights into the market and potential experiments that they are doing. They may discover new things on their own, right? And that itself can get channeled into a new source of potential companies and innovations. On the other hand, since some of the technology is being developed by faculty, they may also find connections where these technologies can be used in those kind of ideas. Since they are co-located, working with faculty, this cross connections can happen a lot more. But for this model to work, additional investments are required. Like that is why the innovation startup policy has said each institute needs to create an innovation fund. Now this innovation fund is very important because a teaching process is one thing. I can come teach a course and go, right? But mentoring a student, creating this thing, that's a different activity altogether. That needs to be supported both for the faculty and the student. There has to be some support to do this kind of activity. Similarly, student clubs, there will be a lot of clubs, design clubs and other things among students. That is one kind of activity, but good partnerships can be forming in those clubs. So if some of the student partners who are forming these clubs and are finding some mutual interest, they are the ones who need to be brought forward and encouraged to create companies. And then you have this incubation ecosystem. So developing, like you have this Atal Innovation Incubation System. We have what is called Made It Innovation Foundation. These are the other sources where they can bring additional funds and create this entire ecosystem, not only for students and faculty, but outsiders as well. Like what Dr. Mohan was saying, inviting local companies, local startups and rural area students who are interested, encouraging them to come into this process. So when you start doing this, you are actually doing something which is nurturing new companies. It is no longer working with mechanical patents or something which is in a paper. You are working with people. You are working with live entities called new companies. It is almost like you are creating babies of this university. These things have a far more deeper engagement and attachment with the institute over time. So not everybody will succeed, but even assuming the normal death rate in startups is say 1 in 10 only succeeds or 90% will die, that's a kind of normal thing you'll see. But when you provide this kind of nurturing ecosystem, you can push that success rate to at least 50%. Now, somebody like IIT claims they do 85% success rate, but that's a very high number. But at least having 40% success rate is a very good shift that one can expect. And if you get to that stage, then you are actually creating companies which can potentially be giving you your future corporate R&D partners. That is the model the entire new education policy or the national innovation startup policy is trying to encourage. So this becomes a student-led model, and this whole ecosystem can slowly start changing from being a faculty-centric, cost-centric model towards a student-centric model and a revenue-generating model. But what you should note here is these linkages will not happen on their own. Network needs to be formed. Because we all have various degrees of freedom. A student has 100 degrees of freedom, a faculty has different degrees of freedom in an academic setup. A network means somewhere these people have to connect. Only with these connections happen and a few groups form out of that, those groups are stable for a reasonable period of time, then only some companies will emerge. And this cannot be forced. This cannot be mandated saying everybody should start a company or everybody, it cannot happen like that. It can only happen through more dialogue at the grassroots level, which may lead to some pattern formation. So that is going to be a kind of a challenge for faculty and students and the clubs and coordinators to facilitate this active dialogue at multiple levels and nurture partnerships wherever you see some groups forming, find ways to nurture them and grow them. So this is the kind of perspective which needs to be adopted, and then we can actually move towards a different kind of model, which I believe is more relevant. Especially look at our institute. It's a small institute. It's only about 60 or 70 faculty and some 1500 students. We cannot talk like IIT Madras. There are 8,000 students and 700 faculty or 600 faculty, right? That 60-year-old institutions. Ours is a 10-year-old institute. We cannot talk in the same way, but we can build something like this, which is very different from what others are trying to do. And that's what we have been doing last few years. We have been nurturing a model like this. And so this is, in my view, this is a much more realistic and a more impactful way towards commercialization of institutional technologies. Now, how does the national education policy support this? If you look at the basic elements of new education or national education policy, the brown ones are all fundamentally related to this innovation and startup ecosystem. And look at what are the drivers for this? It is your flexibility in the curriculum and changes in your pedagogy and student activity and participation in the campus. These three elements, if we actively work on, this is where the people running the curriculum or the people who are working on this IIC and other clubs and all, they need to actively play a role in terms of promoting this. And that can lead to a different kind of ecosystem within institutions. So new education policy also encourages this. Now I'll just cover a couple of points which may be of more practical immediate relevance. Is one of the questions which will keep coming up when you start this commercialization process is, how do you value technology? How do you estimate the cost behind this? Now, one of the preferred approaches is to value the technology from a buyer's perspective. You are selling something to a buyer. The buyer should see value in that. What is the impact on the buyer's business? If I give him this technology, what is he going to do with this, and what is the kind of revenue he will make? That assessment needs to be done, and using that you can arrive at what is the cost of your technology or what is that you want to sell. Now it also depends on the readiness of your level of your technology and all this, and based on that the negotiation for royalty really needs to happen. That's a market driven perspective. Now this requires a lot of skills and expertise within the technology transfer office to do that. But in academic institutions, it cannot be a rule-driven process saying all companies, whether you give this much rate and go. That kind of model may not work. You need to have evidence and supporting documentation for why you are arriving at a certain decision. But it cannot be a standardized rule saying every company will give standard 2% royalty. No, depending on the business, it may vary. Depending on the kind of target audience, it may vary. If you are licensing it to your own startup, a student-led startup, you may even waive off, saying that, look, he is somebody whom we are incubating, and we don't have to take a royalty on that. Let him grow the company, and when the company grows, he will return us through some other forms, right? So after he reaches a certain level, then you charge royalty. So there are different ways in which the contracts need to be structured. Second is, there is a need for institutions to start understanding the cost in development, especially when it is for faculty-led technology, not the student-led ones, but faculty-led technology. This faculty needs to start understanding. So what is the real cost involved in building something? Now, how much faculty time has gone into it, how much student time has gone into it, how much lab infrastructure has been utilized for this, how much patenting cost will be involved in this, how much marketing cost will be required. All this estimation needs to be done to get a rough ballpark of how much effort are you spending on this technology. So it can give you a baseline saying, okay, this is the minimum cost I have incurred, and what is the revenue that I'll make based on the royalty, and does it match, and within some time frame can I recover this cost or not. So that kind of assessments need to happen, and today it may be a difficult thing because one is many academic institutions do not do this kind of accounting process. The admin departments or finance departments, they do not do this. So introducing this at that level may be a challenge. Second is, at a faculty level, there may not be an expertise to do this. So that is where the technology transfer office, if we are setting up, you need somebody who can sit with the faculty and do this assessment, right? So that kind of support will be required for faculty to address some of these questions. Second, there are a few other issues which at an institute level, people at the vice chancellor level and others need to decide is, how is this license revenue going to be split between different stakeholders, depending on the risk and the contribution that they are making. Similar guidelines for how is the corpus going distributed between supporting faculty research versus student-led research or student-led innovation. So these things require policies at an institute level. And last one is, while the institutes encourage this, there will also be certain kinds of cases which may lead to leakages. So one needs to be careful in terms of basically sticking to that NISP, Institute Innovation Policy, to a large extent helps in address these problems. So those safeguards are also required when you are structuring this whole thing. So this is the model which we have evolved in IITDM, which is a little different from what you will find in any other institution. Given our small scale and different kind of mandate that we have created a model where student-led innovation can happen. As the students come into the engineering program, everybody gets exposure to product design and innovation right from their first semester onwards. And for those who are showing greater inclination, they can use their internship and final project to do more work in that direction and take their idea from a technology readiness level 1 to 4. And this is largely handled by a school of interdisciplinary design and innovation. It is not another department. It is not one discipline, one department type of thing. It's a loosely coupled structure which we have created where it introduces the design and innovation programs as well as allows all students in the institute to come through this particular process. Then you have other entities which you will find in other institutions as well. Then these are tightly integrated with the incubator. So incubator works from technology readiness level 4 to 9. The school works from technology readiness level 1 to 4. And this is the pipeline which we have cultivated over the period of last 4 to 5 years. So now we have started seeing some, last 2 years, we have had about 5 student teams who have come into our incubator from our institute. And another 4 teams have gone and started companies outside us with other incubators or on their own. Another 4 student teams, about 10 teams have come in. And these include teams at all levels, undergraduate, postgraduate, and even a PhD student has done that. So that is the initial results we have started seeing. which is reflected partly in the innovation ranking, Atal ranking. Last 2 years, we have been ranked in between 11 and 20 among all the central institutions. So we are the only IIIT in the top 20 among central institutions in the Atal innovation ranking. So with that, I'll conclude my presentation and I can take any questions you may have. So if there are any questions, I will be happy to answer. So if there are no more questions, then maybe I can thank the organizers for giving me this opportunity to share my perspective. Feel free to write back or post any these things. You can consolidate your points and send me as an email. I'll be happy to clarify at a later point.
Thank you so much, sir. There is no questions. I think everybody is clear with the session. Thank you so much for inspiring us with your knowledge, sir. It's a real pleasure for us to be part of this great session. Thank you, sir. Hope all of you had a great learning experience. Gentle instructions to all the participants. Kindly fill out the feedback form that will be provided in the chat box. Only then you'll be receiving your e-certificates. Now, Ms. Divya, MBA Student Association Joint Secretary of PTU, will deliver the closing remarks.
So, good afternoon, everyone gathered here. I feel honored and privileged having an opportunity to offer a vote of thanks on this memorable occasion. First of all, I extend my hearty thanks to our Chief Guest, Dr. Sudhir Vardharajan, Dean Design Innovation and Incubation, Head School of Design and Innovation, IITDM Kancheepuram, who spared time from his busy schedule to grace the occasion. Today, we had an opportunity to hear your thoughts, and this will surely encourage us in all our future endeavors. Thank you, sir. I owe special gratitude to our participants for their support and cooperation. I extend my heartfelt thanks to our Vice Chancellor, Professor S. Mohan, Puducherry Technological University, for his enormous support. Thank you, sir. I express the most sincere thanks to Dr. N. Sivakumar, Program Coordinator, MBA Department, Puducherry Technological University, and Dr. B. Hemakumar, Convener IIZ of Puducherry Technological University, for their tireless efforts to make this seminar a grand success. And I thank our Chief Executive Officer, Mr. V. Vishnuvardhan, AIZ PECF, who has been the backbone for our MBA department. Thank you, sir. Last but not least, I must mention our deep sense of appreciation to the MBA coordinators and the pillars of MBA department for their immense support. Thank you all.
Thank you. Thank you very much.
Thank you so much, sir.
Thank
Thanks
you.
to
Thank
each
you,
and
Sudhir,
every
sir.
one of you.
Yeah. Thank you very much. Goodbye.
Thank you, sir.
Participants, feedback link is available in the chat box. Kindly fill out and get your e-certificates. Thank you all. Have a great day.